Professor and Head of the Department Information Technology, delivering the lecture on operating system. So I am going to teach you the two subjects, that is operating system and theory of computation. The first, as you know that today is our first presentation. So today we are going to see just the introductory part and the overview of the operating system, vision, mission of the institute and the department, the program outcomes, program educational outcomes, the course outcome, operating system objectives, and evolution of operating system. So you may think that this subject is an operating system, then what is the meaning of why this vision and mission statement of the institute and the department are included here, or why the program outcomes or the program educational outcomes, what is the meaning of all these things, what do you mean by course outcome. So dear student, I want to clear you one point is that we are going for NBA accreditation of our department. So for this terminology, that is the CO, PO, PEO, vision, mission, all this terminology are belonging to the NB, that is National Board of Accreditation. So each and being a student of our IT department, you must aware of the vision of the department, mission statement of the department, as well as the program outcomes, program educational outcomes, course outcomes, and all these things. So let us start this operating system, the third year IT, the fifth semester subject, having weightage 70 marks in the end semester, 30 marks in the end semester. The vision of the institute. It is aimed to provide the finest environment for teaching, learning, research, innovation, and character building so as to mold youth of today into world-class technocrats of tomorrow who would endeavor to increase the quality of life for mankind. And the mission statement of the institute is given here. The vision of the Department of Information Technology, the statement indicates that to create globally competent IT professionals, specifically from the rural area with good moral and social values to meet the challenges of the modern computing industry. Whereas the mission of the department is to create globally competent engineers having ability to analyze, design, implement world-class technology to meet modern computing industry challenges, to provide students specifically from rural area with the skills and knowledge to become lifelong learners, to inculcate the spirit of professionalism, teamwork, research, innovation, and entrepreneurship with moral and social values among the students. The program outcomes, the NBA has defined the 12 program outcomes, means after graduating an engineering course, a graduate must possess these 12 qualities, that like engineering knowledge, problem analysis, development of solutions, investigation of complex problems, and modern tools uses, etc., etc. The next point is nothing but your program educational objective. The 5 program educational objectives has been defined by the National Board of Accreditation. Like from first year, an engineer learn or which quality must be inculcated in his first year, which knowledge or which skills must be inculcated in an engineer in the second year, in the third year, and in the final year. And after graduating after completing this 4-year course, the engineer must possess the better communication, presentation, time management, teamwork, skill leading to responsible and competent professionals, and will be able to address challenges in the field of IT at a global level. The course outcome. So in terms of NBA, the course is nothing but your subject. Means operating system is one course. So for example, database management is another course. So course outcome means after completion of this teaching of this OS subject, what the concept will understand. So these are called as a course outcome. So there are 6 course outcome, that is CO1, fundamental understanding of the role of operating system, CO2, to understand the concept of a process and thread, to apply the concept of process and thread scheduling, to apply the concept of process synchronization, mutual exclusion, and the deadlock, CO5 to realize the concept of IO management and the file system, and the CO6 is to understand the various memory management technique. Now let us start with the first unit of an operating system, that is nothing but the overview of operating system. So the contents, these are the topics in the first unit, that is operating system objectives, evolution of operating system, developments leading to modern operating system, virtual machine, then basic shell commands and shell as a scripting language. So let us see the operating system objectives. First point is to define an operating system. A program that acts as an intermediary between a user of a computer and the computer hardware. It is called as an operating system. So you can see here the operating system between, it is nothing but the intermediate between your computer hardware and the different software applications. So you have the Windows operating system, you have the Linux operating system, you have the Unix operating system, you have the Apple Mac OS, then your mobile operating system or iOS operating system, then you are having Ubuntu operating system. So all these operating systems are useful for to run the different applications with the help of this hardware. The next point is the operating system object. The next point is nothing but the general architecture of operating system. So if we see the figure, the operating system consists of four of the basic part. That is the kernel of operating hardware is the first part. Kernel of operating system is the second part. The shell is the third part, and the user application is the fourth part. The hardware is the physical element of a computer system. It is nothing but the physical part of the computer, such as the monitor, mouse, keyboard, computer data storage, hard disk drive, graphic card, sound cards, etc., etc., etc. The kernel of operating system is nothing but it is the computer program that manages output and input requests from the software and translates them into data processing instructions for the central processing unit and other electronic components of the computer. Shell is an interface for access to an operating system's services. In general, operating system shell user use either a command line interface or graphical user interface, that is GUI. User applications are computer programs that designed to perform a group of coordinated functions, tasks, or activities for the benefit of the user. Means, in simple words, we can say that the division of labor in an operating system is divided into two tasks. Means OS is divided into the two basic components, that is the shell and the kernel. The kernel part of an operating system is the deal with the hardware, and the shell part of an operating system is deal with the user or the who are the application programs are there. So user cannot directly interact with the kernel. So if the user want to get the work done from the hardware, then the user has to give some command to the shell, and shell in turn convert this command into the and give it to the kernel, and then the hardware will work or run accordingly. So we can say the division of labor in operating system, kernel and shell are the two important components for this. Operating system acts as a resource allocator. So for execution of any process, for running of any process, they need of resources. Resource in the sense, the thing you can have your CPU as a one. There are two different types of resources, that is hardware as well as the software resources. So hardware resources means your CPU, your secondary storage, your primary storage, your power supply, keyboard, mouse. All these are called as the you're called as your hardware resources, and your software resources are nothing but your file, or one can say that your database, or any information which is needed to run that particular program is called as the software resources. So operating system, or the job of operating system, is to allocate these resources to that particular process, or to execute that particular process. So it decides between the conflicting request for efficient and fair resource use. Operating system also acts as a control program, means it controls the execution of programs to prevent errors and improper use of computer. Now, next part. So that's all about the definition and the basic function of operating system. So we have studied that OS is nothing but the intermediary between the between the computer system and the user, and it acts as a resource allocator, or OS provides you the platform where all other process they can carry out their useful work. So in simple word, we can say that operating system is nothing but the thing. Without OS, your any hardware is dead. So you take any example, you take your desktop, you take your laptop, or you take your mobile. Without an operating system, your mobile is of no use. Without operating system, your laptop is of no use. So the OS is an important part, or it is nothing but the heart of that particular system. Getting my point or not? Operating system is nothing but heart of that particular hardware. Without this OS, your hardware is of no use. So that's why. So you take any device, OS is must. OS is must, and there are different type of OSs, starting from your Windows, Linux, then Mac, then Macintosh, then you have IBM, then you have Apple, then you have n number of operating systems are available nowadays. So next point in this particular chapter is nothing but evolution or the types of operating system. So you might have studied the human evolution. That is Homo sapien, Homo erectus is the first human species. Then comes it is Homo sapien. Then it is the Homo sapiens sapien. So like this way, the operating system has evolved from 1940 or 1950s to nowadays with a very recent or advanced operating system. So it is generally called as evolution. Step by step evolution take place. As you know that there was a revolution in the hardware industry, that is microprocessor. Initially, we have 8086 processor, then 80386, then 80486, Pentium 1, Pentium 2, Pentium 3, and now we have the very advanced processor available nowadays. So to cope up with this hardware changes, the operating system has also evolved. So there are stages in the evolution of operating system also. So we'll see the evolution or the types of operating system one by one. That is simple batch operating system, multi-program batch operating system, time sharing or the multitasking system, the parallel system or the tightly coupled system, distributed system or the loosely coupled system, and the real-time system. So this one can say this is the first generation operating system. The simple batch OS is the first generation OS. The second generation OS is nothing but the multi-program batch operating system, third generation operating system, and nowadays the fourth generation OS are the real-time system or the distributed system. So we'll first see the simple batch operating system. This operating system is just transfers the control from one job to the next job. Job with similar needs were batched or combined together and were run as the batch. Job of similar need combined together and given as an input to the computer to run, and output appears after some time. So CPU often remains idle because of speed difference of IO devices. So in case of simple batch operating system, the concept was that initially the punch card they were used as input devices, and the card readers are there to read this punch card, and the printer was only the output device. So what they used to do is that they have to suppose if you want to give the input like this 1+1, so you have to punch the cards were there, and they need to punch that card, and the input is given to that particular operating system to find out the output of that 1+1 addition. So what they did there, they combined the jobs with the similar needs together, and they form a batch, and they are now calling it as a batch operating system, and this batch is given to the system at one time. So what happened in this case, you'll see here, job 1, job 2 up to n job, they are having same type of need there, and all the job having similar kind of need in the sense, what is the need means they require some same type of resources, they require same type of input, they require same type of output, so same type of resources they require. So that's why they combine together and they are given as input to your operating system. Just like, for example, we are forming the batches. For example, in your third year IT, we are forming the batch of TIT1, TIT2, and TIT3. The three batches we are forming here, right? So TIT1 they are having their operating system laboratory practical. At the same time, TIT2 they are having their database management laboratory. Getting this point? So the students they are sitting in a OSL lab. They are all performing OSL practical. The student they are sitting in a database management lab. They are performing all that practical. So the same way, the jobs or the processes they are having the same kind of need. They are combined together and they are given as input to the operating system in a particular batch, and this batch is executed by the CPU, and then the output is printed out. So in that, the drawback in this particular simple batch OS is that the speed difference between the mechanical and the electronic device, your processor, the electronic device, and the printer is the mechanical device, there is a speed difference. So what was happened there, the process get executed and it is given to the output, but the printer is not as fast as that of your CPU or the processor. So the CPU has to wait till the current job is to be printed. So this speed difference is matched, or this speed difference is removed with the one technique, and it is called as the spooling. That is nothing but the simultaneous peripheral operation online. So spooling refers to the putting data of various IO jobs in a buffer. This buffer is special area in memory or hard disk which is accessible to IO devices. So initially what happened? So assume that, so initially the disk was not there. The card reader directly copied into the CPU, and the CPU execute that particular input and given it to the printer. No disk was there, so that there is the speed difference between your CPU and the printer. The CPU has to sit idle till the printer prints the current job. So in that case, what happened? So in that case, they introduced the new structure that is called as a disk, or it is nothing but the buffer, where whatever maybe the input is given, so you just copy that input into the disk and form a queue of all input, and one by one you are going to take the input from that particular disk and given it to the CPU for the execution. The same case, when the output appears, when the job is executed completely, that output is stored inside the disk first, and one by one job output is given to the printer, so that printer work of printer is continue, and work of your CPU also get continue here. The next type is nothing but the multi-program batch operating system. So in case of multi-program batch operating system, the multiple programs. So the question may arise, in your mind that how is the multi-programming, how the multiple program are executed by the system. The logic is that the sharing the processor when two or more programs resides in the memory at the same time is referred as a multi-programming. Multi-programming assumes a single shared processor. So multi-programming increases CPU utilization by organizing jobs so that the CPU always has one job to execute. So you can see here, so in the operating system keeps all the job in one queue, that is job 1, job 2 up to job n, and out of this all n job, one job is selected for the execution. An operating system does the following activities related to the multi-programming. Operating system keeps several jobs in memory at a time. This set of job is a subset of the jobs kept in the job pool. The operating system selects and begins to execute one of the job in the memory. The multi-programming operating system monitor the state of all active programs and resources to ensure that the CPU is never idle unless there is no job to process. Means it ensures that the CPU must get at least one job for its execution. It's ensure that the CPU will not remain idle for a single amount of time. CPU remains always busy. It will always execute, or it has always one process for its execution. The advantages of this multi-program batch operating system is high and efficient CPU utilization. The user feels that many programs are allotted CPU almost simultaneously. The disadvantages are CPU scheduling is required. Then to accommodate many jobs in memory, memory management is required. So the main advantage of this multi-program batch operating system is the utilization of CPU utilization. So utilization of the CPU is to maximum capacity, or the 100% utilization, means you are allowing your CPU to execute each and every instruction and not allowing your CPU to sit idle for a single moment of time. So meaning is that your efficiency of your CPU increases, or you are utilizing your CPU up to maximum its capacity. The next part, or the next we can say that the type of operating system is the time sharing or the multitasking system. So multitasking system, they are also called as the time sharing system. So multiple tasks are executed by the operating system at the same time. So general definition is like that, but how exactly it is carried out? So we'll see this. An operating system does the following multitasking activities, like the user gives instruction to the operating system and receives an immediate response. The operating system handles multitasking in the way that it can handle multiple operations at a time. Multitasking operating systems are also known as a time sharing system. So why? Because a time shared operating system uses the concept of CPU scheduling and multi-programming to provide each user with a small portion of real of a time shared CPU. A program that is loaded into the memory and is executing is commonly referred as process, as everybody know that. So since IO devices runs at a slower speed, it may take a long time to complete. During this time, a CPU can be utilized by another process. So the operating system allows the user to share the computer simultaneously. As the system switches CPU rapidly from one user to the next user, each user is given the impression that he has his own CPU, whereas actually one CPU is being shared among the many users. So the actual concept is that you can, for a very simple example, on your machine. So at a time you suppose if you have open a file, Word file, and you are typing one document in that particular Word file. At the same time, you are downloading some movie at the background. At the same time, you are listening to them. You have opened some music player and you are listening to the music, right? So how many processes are going now? So there are 3 to 4 processes, they are going simultaneously. So typing is one process, then listening the music is another process, and downloading at the background is the third process. So 3 to 4 processes they are currently going on. So one can say that this is nothing but the time share example of time sharing or the multitasking. The operating system is able to handle this multiple tasks at the same time. So from this diagram, it is clear that you have the word processor, you have the email, you have opened the web browser, you are you are now listening the music, and all these things are handled by your operating system at the same time. So this is the concept, real concept of your time sharing or the multitasking system. Next is nothing but the parallel system or the tightly coupled system. Operating system evolution, the higher level of the higher level at the evolutionary stack. So this is also called as the multi-processor system, having more than one processor situated in a close communication. They share their clock, memory, and other peripheral devices. This is also called as the tightly coupled system. They are having advantages like this: they increase the throughput by increasing number of processors. So more work is done in a shorter period of time. It can save money as processor share peripheral, IO, and power supply, etc. It also increases reliability. So parallel system means we can have, it is a multi-processor system on a single motherboard. You can have 3 to 4 processors are mounted, and this on a as they are situated in a single motherboard, they do not have to share they do not have extra power devices. They do not require any extra cabinet. They do not require any extra memory or secondary storage, etc. They are going to share all these things. They are going to share the power supply. They are going to share the cabinet. They are going to share the main memory as well as the secondary storage. So these are the advantages. And one more, and the important point is that when one processor fails there, other three, suppose if there are 4 processors, out of 4, if the one processor fail, the remaining 3 processor they carry out the work. There is no system failure at all. So reliability of the system increases with this architecture. So from this figure, it is clear that suppose, for example, if a single processor takes 5 minutes to execute a particular job, so if you divide that work into 5 different processors, and each processor will take 1 minute. So within 1 minute, within 1 minute, that job is completely executed. So this is the power of the parallel system or the multiprocessor architecture. Next operating system or the next type of operating system is the distributed system or the loosely coupled system. So exactly opposite to the previous one, that is a parallel one, the distributed system, where it uses the multiple center processors to serve multiple real-time applications and multiple users. So data processing jobs are distributed among the processors accordingly. Processors communicate with one another through various communication lines such as high-speed bus or telephone lines, etc. These are also referred as loosely coupled systems or distributed systems. Processors in distributed systems may vary in size and function. These processors are referred as sites, nodes, computers, and so on. So in a simple word, we can define this distributed system. It is nothing but your the computers, they are in a situated in a LAN or WAN. They are called as your distributed system, or your internet is also an example of distributed system, where each and every processor, it is separated physically, they are separate from each other, and they are having their own power supply, they are having their own memory, their own secondary storage, and all these things, they are having their individual, but they are going to share the data with the help of different wired communication or wireless communication. They are generally called as the loosely coupled system. Example or the diagram, from the diagram it is clear that in a internet we have the different system, that is we have the mainframe, we have the microcomputers, we have the supercomputers, and they all are connected, and they are forming your distributed system. The processors having different power, different capacities, but they are going to share their information and their data through different communication media. And the last type of operating system is the real-time system. A real-time system is defined as the data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. In such system, operating systems typically read from and react to sensor data. The operating system must guarantee response to events within fixed period of time to ensure correct performance. In a simple word, we can define real-time system as the system which are used for the critical applications. For example, your military applications, your aerospace applications, your satellite navigations. So where the time bound limit is very hard. So in that case, the system take the input from the sensory data. The sensor gives the input to your system, and depending upon the information received from the various sensor, the operating system will work and it will take the decision. And decision is taken by the operating system, and accordingly, the hardware works as per the instruction given by operating system. So these are the example: traffic management. You have the intelligent traffic management. You have the security system. You have the aircraft flight control system. You have the microwave oven system, ultrasound machine. That is your camera, printer, audio system, television. So they are all using your real-time system. They are related with the day-to-day activity. So in today's session, we have learned the two main topic in the today's session. That is nothing but the operating system objectives and evolution of operating system. The course attainment of the sessions are the fundamental understanding of the role of operating system, and this now the short answer question that may be asked. So various question, as you know that in end semester examination as well as in the end semester examination. So the following questions have been already asked. That is, the first question is to define the operating system, the very basic question. So you need to define OS correctly. Describe operating system components. Already we have discussed that is the component of operating system. Which are the different types of operating system? That is nothing but your simple batch OS, the multi-program batch OS, multitasking, and the time sharing, real time, all these things. Write a note on time sharing system. Then differentiate between the parallel and distributed. You have to enlist the differences between the parallel and distributed system. So for the references, you have to use, and my request to all the students is that do not use any local author book. Now stop your habit using local author book. You have to go only for the reference book. Make a habit to use the reference book. The OS reference book is the author is by William Stanning. The internals and the design principle and the 8th edition book is there. Also, you can have the NPTEL video lecture. NPTEL video lectures you can refer for the topic, and the web resource for this current topic is this. So that's all for the today's session. So first two points we have discussed in the today's lecture. So if you have any query or any doubt, you just put it in the chat box. Is it clear to all of you? So Hello. Now you can unmute yourself and you can ask audio also. Hello. Hello. Any doubt? You can still ask. You unmute your microphone and you can ask. Yes, Kolapkar. Kolapkar.
Hello, sir.
Hello. Yes. Hello. बोला ना. Hello.